Hello students, let's solve one problem from ray optics. So the problem is an image of an object by a plano convex lens at a distance of 8 meters behind the lens is real and is 1/3 of the size of the object. The wavelength of light inside the lens is 2/3 times the wavelength in free space. The radius of the curved surface of the lens is we need to determine. So it will be either 1 meter, 2 meter, 3 meter, 4 meter. So let's see how to solve. Before we solve the physics problem, we should first visualize the problem. So let us draw the picture. Here is our plano convex lens. This is the principal axis. The image is formed at 8 meter behind the lens. So here it is, the image which is 8 meter behind the lens. It is real and is 1/3 of the size of the object. That means h2, the image height is 1/3 of h1. So this is h1. So u not provided. We may have to determine this. So h2 is 1/3 of h1 provided. What else provided? The wavelength of light inside the lens is 2/3 the wavelength of in free space. That means lambda 2 is the wavelength of light in medium, in the glass or in the lens medium, and this is lambda 1. So as we know, that means this information is giving the refractive index of the lens. So as we know, n2 would be equal to lambda 1 by lambda 2. So lambda 2 is given, lambda 2 is 2/3 of lambda 1 being the wavelength of light in free space. So if I do here lambda 1 by 2 by 3 lambda 1, I should get here 3 by 2, which is 1.5. That is the refractive index of glass, n2 equal to 1.5. So we got the relation. Now we can use now the lens maker's formula. So the lens maker's formula says that 1 by f is equal to n2 minus 1 by r minus 1 by r1 minus 1 by r2. Now let us pay attention to the lens curved surfaces. So the lens curved surface is r1, which is plus r, we can say, and r2 is a plano. So as it's plano, it should be minus infinity. Therefore 1 by f is equal to 3 by 2 minus 1 by r minus 1 by minus infinity. So I should get here 1 by f is equal to 1 by 2 and then 1 by r plus 1 by 0. So then this becomes 1 by f, 1 by 2 r. But now the focal length of the lens is not known to us. So what to do in this case? Let us use this part of the information now. You can see the image is formed at 8 meters behind the convex lens. So u is not provided. So we may use it. So how can I find the value of u? We can use the magnification formula of lens because height information is provided. Therefore we can write magnification m is equal to h2 by h1 is equal to v by u. So h2 is 1/3 of h1. So I can write here 1 by 3 h1 by h1. I should get here v by u. So that means 1 by 3 is equal to v by u. But v, as we can see, is provided 8 meter. Therefore we can write is equal to 8 by u. That means u is equal to 24 meter. So I think this information is sufficient enough to use in this relation. So we can write 1 by f is equal to 1 by v minus 1 by u is equal to 2 by r. So v is going to be 1 by 8, and u, sign convention, using sign convention, I can write this as minus 24 is equal to 1 by 2r, or we can write 1 by 8 plus 1 by 24 is equal to 2 by r, or I think 24 is the LCM. 8 3 plus 1 equal to 1 by 2r. So I should get here 4 by 24 equal to 1 by 2r, or 4 6 is 24, 1 by 2r, or r is equal to 3 meter. So the radius of curvature of the plano-convex lens, the curved surface, is 3 meter. So that would be your answer. Thank you.